G'day, I'm Tim. I'm the co-founder and CTO of an early stage, or seed stage, if you're familiar with venture funding, seed stage startup based here in Sydney. My co-founders are over in the US, but our engineering team is based here. We started just over a year ago, and we're building AI agents for application security on AWS Serverless. But shout out to Brent for giving a bit of a background of AI. So there's not two domains that you're completely foreign to. I hope you know a little bit about serverless at least, but maybe that's why you're here. So what are AI agents? You may be familiar with existing software agents that you probably use day to day, like web indexing agents, like Google's web indexer crawling the internet, indexing it, providing a database for Google search. If in your corporate systems, you may have email scanning agents that are looking for spam or phishing attacks, and filtering those out or alerting you about them. And you could have your work laptops probably have endpoint agents running on them, checking for, I don't know if you've got screen lock on, but maybe they're running virus scans. The servers that some of you, or I guess it's serverless, but if you're running traditional servers, you may have some agents running on those to monitor CPU usage or RAM usage. These are traditional software agents, and AI agents are effectively a subset of those, but obviously they're using AI, not necessarily large language models, but this is going to be more about how we can use, how can we build AI agents with large language models. So we start with a really simple program architecture. So I'm just building CLI programs here. We're not serverless running on the cloud yet. So a simple CLI app takes in one command line argument, which is your question. This is a simple chat bot. You can see there's two messages in the message history we're going to pass to OpenAI, and it's going to complete the chat for us. The system prompt, so the user, the role is the system. That just, you can give a whole bunch of background context to, make this GPT model behave a certain way. We're trying to build a little weather expert app just to make it really easy to understand what's going on here. And then we feed in the question from the command line arguments. Then we're calling the chat completions API with GPT 3.5 Turbo just because it's fast. And then we're printing out the response. If I ask it a question, what is the weather in Sydney today, it either hallucinates and just tells me something random because it doesn't know real-time weather data, or, which is probably worse, but sometimes it does tell you, I'm sorry, I can't provide real-time weather updates, which is probably better, but these are two outputs from the same piece of code. Like, you don't know what it's going to do. We heard a little bit about tool calling, but I'm going to go a bit deeper into it with some examples. So let's try adding some tool calls. So this is the next step of our program architecture, where we take the same user input, we're registering some tools, which I'll go into in a sec. We're invoking the LLM the same as before, but this time the LLM is deciding, do I need to call this tool? This get current weather function that I've provided. If you ask it a question about what is the current weather, it will decide to call that tool, which you can go fetch the data from an API or some Bureau of Meteorology API, or it'll just answer the question and you get the output. So we start with the same start of the program, the same chat history. Then we're going to define our get current weather function. Here I've just hard-coded that this temperature in Sydney is always 15 degrees, but you could actually implement this function to go call a weather API to get real-time data. Then we define this JSON schema for the function. So we have to give it the name and the description of what the function does. This is really important because it tells the LLM what the function does, so it can reason about whether it needs to call it or whether it doesn't. And then you define the JSON schema for your parameters of the function. So it takes in one property, the location property, it's of type string, and it can be the city. And it's a required field. So that's just standard JSON schema. Then we're going to call the LLM with our list of tools. We only have one, but yeah, so we're adding this line 51 there, tools equals tools. And then you can see on line 58, we're checking if the LLM wants us to call a tool or not. So if this tools list is populated in the same response, we're going to call a tool. If otherwise, we're just going to print out the chat response. So if the LLM does want us to call this getCurrentWeather tool, yeah, we go and get the tool call.function.arguments, and we're going to pass that into the getCurrentWeather function. And then we're going to pass the results back to the LLM in the message history, append it to the message history. And then we pass that message history back into another call of the chat completions create function. And then finally we get this call doesn't have the list of tools, so it forces it to output a chat response. So how does this program behave? So before, it wasn't able to answer any real-time weather updates, or it was hallucinating. After, it's showing an accurate answer where if you ask it, what can you do, it can tell you, I can give you real-time weather updates. If you ask what is, and that's where it's decided it doesn't need to call our tool, so it's reasoned. And in the second example, when you ask, what is the weather today in Sydney, it is able to give you the current temperature is 15 degrees, which is the value we hard-coded in that function. So what next to grow it from here? We can add more tool calls to query databases. We can perform various actions. So you can build, we are starting to build an AI agent that can, it could do anything, not just query weather API, but it could interact with any environment, any code that you want to run. You just give it a description and the LLM can decide to call it or not. And you can add it in a loop so that the LLM can continuously decide to call functions, get the results, feed the outputs from that back into more functions, and it can do things like it could loop 10 times before it decides, I'm done with my task that you've given it to do, and it gets to the end. So that's a bit of a background about AI agents. Hopefully that was simple enough to understand. Now we're going to go into some problems in application security. So we'll start with just some vulnerable code. SQL injection, I hope you're all kind of familiar with that already. But you can see on line 7, we're just doing a string concatenation of the username into our query. If that username is provided as like an input to this function, into this program. So if a malicious user wants to put in the username, semicolon, drop tables, or like escape the quotes, semicolon, drop table users, you can drop your database. And another type of vulnerable code, there's many, but here's a couple of simple examples. If we're doing like JWT token validation, which is used commonly in like APIs for granting access to an API or not. Here we've accidentally put the token checking algorithm as jwk.none, which means it doesn't actually check the token. So anyone could access this API just off this one tiny variable. Another type of category of vulnerabilities is like authorization logic bugs, which are a bit harder to detect with traditional tooling. This is a secure example where we've got the requires auth and the requires role admin on this endpoint. So it's only authenticated admin users can access it. But what if we accidentally forget to put the admin role check on this endpoint? Now, in some cases, if this is the GitHub API, their endpoints to get all the users of GitHub is public, and you don't need to be authenticated. Anyone can do it. But if this is a insurance company or bank or something, you probably don't want random people on the internet to be able to go and get all of your customers and maybe some of their data. So given the context of what application this is and what business context it is, this could be vulnerable or it could be okay. But shout out to Optus if you even forget to check like the authentication. Then anyone can call this endpoint and dump your whole customer database. I'm sure a lot of you are probably familiar with the Log4j vulnerability that happened, but just another kind of class of source of vulnerabilities in application security. It's the third-party packages. This was like one of the worst ones in history, where there was like remote code execution if you're using particular versions of the Log4j package. Becomes really difficult when this happens because it's hard to find all the locations that packages are being used. But then there's also more malicious vulnerabilities in third-party packages where, in this case, the poor maintainer of this NPM package had their NPM account hijacked, whether it was, who knows how that happened, but an attacker got hold of their NPM registry credentials, and they published a whole bunch of versions of this UA, like user agent parser JS package that had malware in it. And you can see there was just absolute chaos going on in this GitHub issue about the incident. People like they have their luckily Windows Defender was picking up like Trojans on their computers, but it's not ideal. Like, and especially combined with auto updaters like GitHub Dependabot. As soon as this attacker's uploaded the malicious code, this Dependabot's updated, your CI systems run, your build servers have downloaded this this Trojan, especially if you're self-hosting like long-running GitHub action runners or something in your private networks. Automatically they can all just be downloading these Trojans, and all your machines are compromised. There's other things like devs just hard coding secrets. Where it can go really wrong is if it's a public repository, but also even if it's a private repository, even AWS with they acquired Twitch, and the whole Twitch code base somehow got leaked. If there are developers hard coding a bunch of AWS keys in the Twitch code base, like that would have all been public. So you do want to mitigate that, source code being leaked. They can chain together, like if developers are accidentally downloading a malicious NPM package, malware's on their machine, it can go get these hard-coded credentials from the code on that machine and exfiltrate them. So they can all be kind of chained together. There's so many combinations of what can go wrong. But all of this combined with kind of a talent shortage of application security. This is probably a conservative estimate of like one security engineer for every 100 developers, and that's just security engineer, not application security. Like there's so many other fields of cybersecurity that security engineers work on. So you can see this is a very hard problem to solve. But there are a lot of AppSec vendors out there producing tools to help solve this problem. What are the current problems with them? They have a lot of false positives, which particularly pisses off developers because they mainly do detections via like simple rule-based pattern matching on code, or they do brute force scans of your applications. So this code in the bottom left, it looks like an SQL injection. It's similar to that one before, but the username is actually just hard-coded as a const in this case. So even though it's not great to have code like this around, but it's not actually exploitable. And you don't want it to just create unnecessary noise in developers' environments. There's also a lot of false negatives. Like if you're just trying to do brute force and pattern matching to find vulnerabilities, like to write patterns and detections for every type of vulnerability that can happen is very difficult. But there's also types of vulnerabilities where you need to take in the business context, or maybe it's a custom bit of malware that's really hard to detect. It doesn't come up like some malware byte scan. So the current non-AI based tooling isn't able to detect this type of stuff. So how can AI agents help solve some of these problems? We're going to focus on one real simple example. Obviously, there's many things that we could do, but to alleviate some of the work that's created, but for developers to go and fix these vulnerabilities, we're going to look at how we can build a code fixing agent. So the problems we're trying to solve, code scanners find a lot of potential vulnerabilities. It's a lot of work to go fix them all. But what we want to watch out for, obviously AI agents are not 100% accurate, so we have to take that into account when designing this agent. Things we can do to mitigate that, we can run evaluations on the fixed code, like syntax checkers, formatters, rerun the vulnerability scanner if it was found by like a vulnerability scanner. But we can also leverage the same mechanism that developers use to review each other's code, to have a human in the loop with this agent. That's GitHub pull requests. So the input to this agent is going to be a vulnerability, like the type, a file path, start line, end line of where it is. And that's the code. The tools we're going to give to this LLM, how before we had the weather, like get current weather function. Here we're going to have just like read a file, write back to the file, run the vulnerability scanner, and then run a compile syntax check. So those are the four tools we're going to give this agent. So here's a very simple kind of agent architecture for how we can do this. We start on the top left with that vulnerability. We're going to clone the code. We're going to register our 4 tools. We're going to call the LLM. The LLM is going to decide, is it finished? If it's the first time, you'd hope it says no because it hasn't done anything yet. So we go up to execute tool. It's either going to write file, read file, rerun a scanner or vulnerability, or syntax check, sorry. And then it's going to continuously loop calling these functions. You can let the LLM reason about how the best way to fix this vulnerability is, but it's interacting with the vulnerable file, and it knows exactly where the vulnerability is. And eventually, it'll think, it's finished, it's made the code change, the vulnerability scanner's passing, the syntax is all correct, and it's going to finish. And how can we trigger this agent? So we mentioned GitHub pull requests, but we can create a GitHub app where we can subscribe to all the events happening in GitHub, like commits pushed, pull requests opened, comments created, pull requests, reviews submitted, all these things that can trigger the agent. We're going to do triggering off this GitHub issue for the vulnerability, and then you can reply to it saying, please go and fix it. So here's a quick demo video. Don't have to worry about just committing up a vulnerable file. So we have that SQL injection vulnerability in this file. We're going to push it up to our GitHub. So you can see that code is pushed up. Nullify is running a scan. You can see it does container scanning and everything and whatnot. But it's found this SQL injection. It's created the GitHub issue. So here's, it's created this GitHub issue for the vulnerability. We can reply in the comments section to please, Nullify, please fix it. And then it's going to go off and trigger that agent, which is running in the whole agent is running in one single Lambda function. You can see it's responding. It's saying just a minute. It's working on a pull request, and here's the pull request that it's created. So it's created that pull request. Here's the description of the fix it did. Here's the code change, and now here's the human in the loop. It's done a correct fix. There's nothing I can really review, but I can ask it a question. We see it as a bug if it hasn't fixed it correctly, but if it did something you wanted to do differently, you could say, hey, use a different style. Maybe it used camel case over snake case, and you wanted to fix that. But we've asked it a question on how to exploit this vulnerability, and then it said, here's the input. If the username is that, or 1 equals 1, then it'll return all users instead of that 1. So you could exfiltrate that data. So we're going to approve this pull request now, merge it, and then it's going to then rerun the scan, like a vulnerability scanner, and then the vulnerability should now be fixed. And almost there, done. The vulnerability has now been fixed in our main branch, and the issue is closed. So that's the agent kind of trying to perform like, or have the same kind of user experience that you would have with another engineer. Cool. So what kind of improvements can we make to this? It's a very simple agent. So, I mean, one, you could use one of these agent frameworks like LangChain or Langroid. We've had some good success with Langroid. And Langroid's kind of a multi-agent framework, so it allows you to do things like have one agent that's doing the fixing and then one that's code reviewing it. Because maybe it's not used the variables in the same style as like the rest of the code, or maybe it's actually changed the behavior of the code. You don't want, like, it may have fixed the vulnerability, but now the program is doing something you don't want it to. So having that second agent that's just reviewing the code change, and then they kind of talk to each other. You can have an architecture like this. We could also ingest the CI status log. So if it pushes up the pull request and the code change has broken some tests, we can then ingest the development teams like CI logs and see, just like a human would, like, oh, I pushed up a change, the tests failed, or whatnot. And then it could feed those results back into the agent, and it can keep iterating until it finds a fix that passes your CI pipeline. You could also include a data set of validated code fixes. Like sometimes, in the same way, when you're chatting with ChatGPT, you can sometimes get in this loop where it just can't figure out the answer. That could happen here because it's just missing data on how to do the task you want it to. So if you find you're hitting a lot of those use cases, you can build up a data set of that knowledge, in this case, like validated code fixes. You could store that in a vector database, or you could fine-tune, but probably start with a vector database and just do a RAG system where you're just doing a similarity search on similar vulnerable code that you have a verified fix for. You could do you could add some code searching LLM tools. So this is like GitHub code search on the right. Because what if your vulnerability fix changed the definition of the function that the vulnerability is in, like added a new input or removed one? Then you have to find all other locations in the code base that are using that function and update it there. So you have to do this code searching. And shout out to Ben. Please go to his talk later today. He runs code search. So it's a very interesting talk if you want to learn more about this kind of stuff. Some other improvements, you could have a data set of plans. So if we let the LLM decide what tools to call in what order. But if you can see a log of the approach that it's taking to fix a vulnerability or to do any task, and you see it's just its ability to plan and reason about the problem is just not there, that's when you can start like handcrafting particular like plans of what order and what tool calls to make. So say if you have a Docker image that uses the root user and you want it to harden that by changing it to use a non-root user, you may first check what the base image is, so you know what the command is to add a new non-root user. Then you may want to go and search through the whole code base to find any code that requires root privileges to run, because you don't want to fix that vulnerability and break the code base. So that's where you may have a bunch of tool calls for code searching, whether it be like searching for usages of a function, or it could be more like a similarity search from like a behavioral point of view. Like, find me some code that requires privileged operations. And that's where you kind of need to get embeddings model that is encoding like all the information about what a piece of code does. If it can encode that information, then you could use a vector database of your whole code base to help with that. And then you may want to remove privileged of calls if possible, and then it either fixes the vulnerability or sometimes it's just not able to. But yeah, you could have this database of plans for how to fix different types of vulnerabilities to help the agent with its reasoning capabilities. So we have a version of this agent in our product, and it's built on AWS Serverless. And obviously our architecture is way too elaborate to fit on one slide and still be understandable. So I've just made a real simple one. So we received the GitHub webhooks for like the issue comments that how we triggered the agent, PR reviews, and the GitHub action statuses. We receive webhooks for that into API Gateway, calls a webhooks Lambda, which can convert the GitHub webhook into more like a standardized form, so you could support other version control system platforms, GitLab, etc. You could put those events on EventBridge, where our agent Lambda can subscribe to it, and it either invokes the chat agent or the autofix agent. And then the output results of the agent are replying to comments in GitHub, creating pull requests, and responding to pull request reviews. So other use cases in application security for AI agents, we just touched on the code fixing or vulnerability fixing in code, but we could detecting authorization logic bugs, where you need to take into account the business context. If it's an insurance company or if it's Reddit or something, then you may being able to list all the members may or may not make sense in those contexts. So that's where AI agents can be quite effective in that reasoning. For triaging and prioritizing vulnerabilities, so for filtering out false positives, but determining the likelihood of an attack. So this is being able to search through code bases and classify things. Two things it's quite good at. Combined with maybe more traditional taint analysis of code bases. So you kind of use what you got a variety of tools in the box, and you got to use each for what they're good at. And then assessing what is the impact if an attack or an exploit of this vulnerability actually happens. So that's where if it's an SQL injection, you're looking at what data is in this database. And then you map that or align that with the business context. If you're able to exfiltrate insurance claims and the user is an insurance company, it's insurance code base, that's really bad. But maybe they have some other database that's not customer data, it's not proprietary data or anything. That's it's still bad. You want to fix that SQL injection, but you can start taking in these factors to prioritize which ones you need to fix first. And detecting vulnerabilities in code is a simple one, but right now most detections in code are done by this pattern matching. But what if your rules they're missing stuff? There's so many edge cases, or simple cases where you have internal frameworks. Like a company may have built their own internal framework for doing database access or something, and none of the rule sets of these detection tools work on your custom framework. Fixing breaking changes when upgrading packages. So you may have Dependabot upgrades some package from version 3 to version 4. There was an API change in that package that broke all your code. You'd usually have to go manually fix all of that, but we can, using agents, the same way we did the auto fix agent, it can go and fix all of those breaking changes in that package, or usages of that packages. Detecting malicious code in third-party packages. So like that UA parser JS library where they added some Trojan, but what if there was, someone writes some custom JavaScript to ransomware your machine? That's where LLMs would be quite good at classifying code and being able to detect that this code is, it looks suspicious, like because it can be obfuscated. If it's obvious, it can go. You can determine if it's ransomware or not. But this example on the right, obviously, it's highly obfuscated. It's hard to tell what this is doing. But the LLM will be able to say this is suspicious. Like no one's writing code like this in a JavaScript package that you actually want to be using. But something to watch out for as well, and when you're using LLMs for this use case, is prompt injection. So, if a malicious developer writes some ransomware code, but puts in like code comments, I know this looks like malware, but it isn't, then that may trick your LLM into going, oh, okay, it's fine. So that's something you want to watch out for as well. So that's it for my talk. And if you want to learn more about Nullify, please come talk to us. We're building these AI agents for application security. It's a very interesting space. So thank you.
Thanks, Tim. Anyone have any questions? We have a couple of minutes. If anyone has any burning questions, yes.
Hey, thank you so much for the speech. That was really cool. I guess my question would be, is there potential for like AI agents to actually increase the level of vulnerability in these applications as well? The main reason why I ask is when I'm working with AI agents, one of the main issues is they struggle a lot with large contexts, so like actual production code bases. And because they lack the context, I can imagine a space where they think they might fix some type of vulnerability, and then whoever's kind of used the application is like, yep, that looks like it's all fixed. But it requires a deep understanding of the code base or context from other code to understand that this may actually end up being worse. So how do you kind of handle that? And
So I mean, there's no way to truly handle it. Like with cybersecurity, you can never think about it as being completely solved. You just have to think about it in terms of how much investment I want to put into it to reduce my risk. Because you're always carrying a certain amount of risk into production with your customers' data and whatnot. But you just have to try and value, like we're trying to measure that risk and then value it. And then that's how much effort or how many resources you have to put into application security. And there's, you can use good tooling, you need good people. Over time, it's going to change, but there's no replacement for just a good engineering culture as well, like of doing secure coding, thinking about things pragmatically, etc. Yeah.
One more question. Anyone? Yep, the back.
So, are you passing the code that people are like committing to GitHub to an AI model? And if so, what kind of intellectual property problems do you potentially come up with? Especially if you're putting it as a security tool. So the idea that you might have some plain text keys in your code and on GitHub, bad. But if you're then passing these to a model as well, what kind of, does this introduce potential problems and risks?
It can, so you have to be careful. But nowadays, these LLMs are hosted as a service, just like any other database service or whatever it is, compute service in Azure and like AWS with Bedrock and whatnot, and they have the same kind of guarantees as all the other services. So I mean, if you want to know explicitly, you can dig through the Bedrock or your Azure OpenAI kind of service agreements. And see exactly, they guarantee they don't train on your data. Obviously, it's a shared compute, but the data isn't, we don't, at Nullify, we don't store customers' code bases at all. We have a GitHub app where we temporarily access your code, and it's only persisted in memory for a short amount of time. So that's how, and we don't store any of the code because, it can contain secrets, can contain proprietary code, really sensitive code. But yeah.
Okay, thank you.